Good morning everyone. Till previous video lecture, we have discussed regarding the single phase AC circuit. Now in this video, we will start a new topic, that is polyphase AC circuit. And my dear friends, this will be the unit number 3 of the paper named or we can say of the subject named electric circuit. Now as we know that alternator are basically used to produce electricity, and single phase alternator has only one armature winding. As we know, there are two type of winding. The first one is armature winding and the second one is field winding. Now in case of single phase alternator, if we talk, then it has only one armature winding. But my dear friends, if we increase the number of armature winding, then the alternator becomes polyphase. And according to the number of armature winding used, different or we can say many independent voltage wave will be produced. That will basically depend on the number of winding. Now as we know that these winding are displaced from one another by equal angles. In case of we can say single phase, basically the winding are displaced by 90 electrical degree, and in case of three phase it will be basically displaced by 120 electrical degree. Now as we know that basically the name of the topic is polyphase AC circuit. Now the first word is polyphase, and it is derived from two words. The first one is poly and the second one is phase. Now as we know, poly means many or various and phase means winding. So we can say that various or we can say numerous phase or winding. Now as we have already discussed that in case of two phase alternator, my dear friends, the phase are basically the windings are displaced by 90 electrical degree, and in case of my dear friends three phase alternator or we can say three phase winding, the phase are displaced by 120 electrical degree. And hence basically for the calculation of phase angle, we can say normally the formula used is 360 by n, where n is the number of winding. Now my dear friends, first of all we will discuss the next topic, that is phase sequence. What is basically the phase sequence? Now as we know that basically in three phase alternator, three different types of phase are produced. The first one is R, which basically means red. The second one is Y, which basically means yellow, and the third one is B, means blue. Red, yellow and blue. And my dear friends, RYB, as you can see here, winding R peak first, and then winding Y, and then winding B. Now my dear friends, as you can see here, this is basically the representation of the winding of three phase alternator. Now as you can see here, if we find out the phase sequence in clockwise direction, then it will be RY and then B, RYB, and then my dear friends YBR, and then we can say BRY. So this is basically the clockwise rotation of phase sequence. And if we talk regarding the counterclockwise or anti-clockwise rotation of phase sequence, then as you can see here, we can say BYR, this will be in anti-clockwise direction, and then YRB, and then my dear friends we can say RBY. This is basically the counterclockwise or you can say anti-clockwise rotation of phase sequence. Now we will move to the next, that is types of three phase connection. Now my dear friends, we know that basically in three phase are present. The first one is R, the second one is Y, and the third one is B, and there will be a neutral which is denoted by N. We will discuss regarding this in this video further. Now there are two types of basically three phase connection. The first one is known as a star or we can say it as a Y connection, and the second one is a mesh or we can say it as a delta connection. Means a star connection is also known as Y connection and mesh connection is also known as delta connection. Now my dear friends, as you can see here in this figure, as you can see here, this is the star connection or we can say Y connection. As you can see here, my dear friends, this is basically phase R, this is phase Y, and this is phase B. Now as you can see here, this is the first phase, this is the second phase, and this is the third phase. Now if we want to find out the voltage between the R phase and B phase, then as you can see here, it is denoted by here VRB, and this is known as we can say phase voltage. Now similarly, if you want to find out the phase voltage between phase B and phase Y, Then as you can see here, it is denoted by VYB, and this is also the phase voltage. And similarly, if you want to find out the voltage between the red phase and yellow phase, then it is denoted by, as you can see here, VRY, and this is also, my dear friends, phase voltage. Now as you can see here, this is VNR, means the voltage between neutral and, my dear friends, red phase. Now one more important definition from here we can get is that, my dear friends, the voltage between the phase and neutral is known as phase voltage. What I have said, the voltage between the phase, that is, if we take this phase, the R phase, then the voltage between R phase and neutral, my dear friends, is known as phase voltage. So here VNR will be phase voltage between neutral and red phase. Now in the same way, this will also be the phase voltage, and this will also be the phase voltage. And now, my dear friends, this will be our neutral, as you can see here. So here we have discussed the two main concepts. The first one is line voltage, which is the voltage between line to line, and the second one is the phase voltage, which is the voltage between phase and a line. Now as you can see here, my dear friends, the displacement angle is basically 120 degree. These all three angle will be equal and equals to 120 degree. And now, my dear friends, from this figure, if we take this R phase as a reference, then we can say, and my dear friends, if we denote this as a V at angle 0 degree, or we can say if we take it as a reference, then we can say VY, my dear friends, will be V at the angle minus 120 degree, my dear friends. As you can see here, this is the R phase and this is the Y phase. And now from R phase, if we move 120 degree in clockwise direction, then we will get the Y phase. And my dear friends, we know that angle measured in anti-clockwise direction is in negative. So here this is the angle measured in clockwise direction is denoted by negative. So my dear friends, this negative basically denotes that the VY phase is in clockwise direction to the VR by angle 120 degree. And now similarly, if we want to denote this by, if you want to denote VB, that is, my dear friends, B phase. If you want to denote the B phase, then we can easily denote V at the angle, my dear friends, this is 120 and this is 120, and the total will be minus 240 degree. If we move in clockwise direction. But my dear friends, we can also move in anti-clockwise direction. As you can see here, this is our reference and this is B phase. We can also move in this direction also, and this is anti-clockwise. So we can also say that VV will be equal to V at the angle plus 120 degree, because my dear friends, this angle is measured in anti-clockwise direction, and we know that the angle which is measured in anti-clockwise direction is considered to be positive. So these all are basically the representation of different terms in a star or Y connection, as you can see here. Now my dear friends, we will discuss the next one, that is we can say, my dear friends, as you can see here, the star connection can be denoted by either using this diagram, or we can say by using this diagram. Now my dear friends, we know that the voltage between line and neutral is known as phase voltage, and the voltage between line to line is known as line voltage. Now my dear friends, we will discuss the next connection, that is delta connection, or we can say it as a mesh connection. Now as you can see here, this is basically, my dear friends, delta connection or mesh connection. As you can see here, this is our R phase, this is our Y phase, and this is our B phase. And here similarly, as you can see here, the voltage between R and Y is denoted by VBR, and this is also the line voltage. In the same way, my dear friends, the voltage between the phase B and phase Y is denoted by VYB, and this is also known as line voltage. And in the same way, the voltage between R phase and Y phase is denoted by VRY, and this is also, my dear friends, is the line voltage. Now my dear friends, as you can see here, this is basically our representation of, my dear friends, the line voltage. Now as you can see here, if we take VRY as a reference, my dear friends, VRY, that is, as you can see here, VRY, this one as a reference, then in the same way we can say that VYB means this one, my dear friends. VYB will be V at the angle minus 120 degree. And similarly, if we want to denote a VVR, then we can say that V at the angle minus 240 degree, or we can say plus 120 degree. Now my dear friends, this is all regarding the delta connection. And my dear friends, delta connection is shown by another method, that is, as you can see here, delta connection can also be shown by this method, where this is R and this is Y and this one is B phase, as you can see. So we can denote my dear friends, delta connection in two way. This is the first way and this one is the second way. Now my dear friends, in this video we will discuss we discussed regarding the basically generation of three-phase EMF, and then the definition of phase sequence, and then we discussed the two types of basically three-phase connection, that is a star connection or delta, or we can say mesh connection, a star connection and delta connection. Now my dear friends, that it's for the video. I hope you have enjoyed this video. That's all. Thank you.